Hi everyone, I hope you're doing well. So in today's video, I'm actually going to go through the 2016 Specialist Maths Exam 2 multiple choice section. And yeah, let's start through this video. Like always guys, before I start this video, if you guys want, private tutoring in specialist methods, physics or chemistry, you can always email me through this email. And yeah, let's smash through this paper. So question 1 states, the Cartesian equation of this relation given by x equals 3 cosecant squared t, y is equal to 4 cot minus t is what? So, okay, this is nice and basic. So, if you look at your formula sheet, you should see this relationship, this circular function relationship. It states that we know that the cotangent, so cot squared of t, plus 1 is actually equal to cosecant squared of t. Yep. And luckily, I know that if I kind of re-express this in terms of cosecant squared, so it will just be, x over 3 is cosecant squared t. We can just shove that into this function over here. So that will, this part over here will be x over 3. Nice. The next part is we just want to kind of re-express this in cot squared t. So this will be y plus 1 over 4, and we're squaring it. That's going to give us cot squared of t. And that, we can rewrite it as y plus 1 squared over 4 plus 1. Nice. Now, what I'm going to do is I'm going to have a look at the answers and see which one looks very similar. None of them look like. What about if I just kind of simplify this extra? So if I just say that's y plus 1 squared over 4. If I bring that 1 to the right side, so it'll be x minus 3 over 3 by simplifying it, and we multiply by 4, it's supposed to be 4 squared. 4, so it's 4 squared is supposed to be 16. I forgot to square that. Yeah, so, and then multiplying, by 16. The other side, we get y plus 1 squared is 16 x minus 3 over 3. Which gives us E as your answer. Nice. Question 2. The implied domain of y r cos x minus a over b, where b is greater than 0, is what? Okay, this is such a, repeating questions in exams, and we know that the inside of arc cos or arc sine only take values from -1 to 1. So if we can let this the inside of the function x minus a over b be between -1 to 1, and we can solve for x now, so it'll be negative b. Be negative b, that's all equal to x minus a, that's all equal to b. So in other words, a minus b, that's all equal to x, that's all equal to b plus a. Which one does that look like? From the answers, it looks like b is your answer. And you can easily do this question using a CAS, by the way. So if you have a look at the CAS, you just have to write domain of arc cos of x minus a over b, comma x, given that b must be greater than 0. And that gives us a beautiful expression. So this one, right over here. Same expression as we got. Done. Question 3. The straight line asymptotes of the graph of the function with the rule of this, where a is a non-zero real constant, is given by what? Okay, now we can easily simplify this. As you can see, there's a common factor of x, so you can rewrite this as f of x as x squared minus a over x. And you can easily use long division to kind of simplify this. So using long division, so x squared minus a over x, we get x on top, that'll be x squared, plus 0, and that will leave us 0 here, and that'll give us negative a. So f of x can actually just be written as x minus a over x, pretty much. Yeah, so this is our expression right over here. Now, using this expression, it's much easier to see the asymptotes. Well, we're going to have, what we call a vertical asymptote at x equals 0, because when you let the bottom of the function equal 0, we get x equals 0, so that's going to be a linear line. That's going to be a straight line. We also have what we call an oblique asymptote, which it's y equals x for this function, And it is also a straight line. So these are your two values of the asymptotes. So x equals 0 and y equals x. So choose C as your answer. You can easily do this by CAS. I'm not going to lie. You can smash through this by CAS. So if you go to our CAS, you can just, go to expand or x to the power 3 minus a times x over x, enter, and it gives you, what have I done here? Oh, I forgot to x square this, actually. And yes, as you can see, it gives you a beautiful expression like what we just got. And yeah, you can also graph it if you want. Yeah, but in these kind of, I want to make sure to show you the algebra. I want to make sure to show you how do you do the questions. So yeah, question 4. One of the roots of z to the power 3 plus bz squared plus this is this. So this is one of its roots, where b and c are real numbers. The values of b and c respectively are what? Okay, so what we know is that we already know one of the values of z, which are, a solution. So z is equal to 3 minus 2i, yes? Now, let's check. Are the values of the constants over here all real? So they don't actually have the value of I, a complex number, I. Yes, as you can see, we know that here's just one. B, which is still a real constant. C is also real. So this fits perfectly. So if they all have real constants, we can use a theorem called the complex conjugate root theorem, pretty much. The conjugate root theorem, pretty much. So we'll write conjugate root theorem here. So what the conjugate root theorem states, if that's how you spell it, so conjugate root theorem says that if we have a solution, the conjugate is also the solution. So for example, this one over here, the conjugate of z, which is 3 plus 2i, is also another solution for this equation. And yeah, so kind of let's write them in terms of factorized form, so it makes our life easier. So this can be written as both solutions as z minus 3 plus 2i, and the other one z minus 3 minus 2i. Okay, so we get this nice expression, and what I want to do is, okay, if I multiply these, this is going to give me z squared for the first expression, but I want z to the power 3. So what I need to know is straight away that, okay, I'm going to multiply this by z here. I'm going to put a factor here. I also know that the end of it has c times z. So it means that if these were multiplied, these two, so it'll be negative 4i squared, which is negative 1, plus 4. This is a constant, but we want it to be multiplied by z. So meaning that this over here will have a z here, pretty much a z. So this over here would give us a beautiful expression for this. So using your calculator and expanding this, you should get, your actual answer. So if I go expand, so z times z minus 3 plus 2i times z minus 3 minus 2i. Expand that. Aha, beautiful expression. So your actual value of b is negative 6 and your value of c is 13. So let's write that down. Your value of b is negative 6 and your value of c is 13. So giving you the answer of the E. Question 5. In the argument of negative 1 plus ai is equal to this, then the real number a is what? Okay, not too bad. So what I'm going to do is, okay, if I was drawing a diagram, an outgoing diagram right over here, and let's call this, the real axis, real is z, and here is your imaginary axis. All right, we know that the polar angle, the angle is, negative 2 pi on 3, which is over here in this quadrant right over here. In this quadrant. So what I'm going to do is, if I just draw an angle over here, I know for a fact that this here should be pi on 3 from this, because imagine that, all right, you start off 0 and, here is, negative pi on 2, and you come in here, this angle from here to here should be negative 2 pi on 3, yeah. So that angle should be negative, pi on 3, And I know this over here from the axis is -1, so -1. And this is the value that I want to find, this value of A. This value of A that I want to find. And how can I do that? Well, easy. Just have a look at this. Isn't this just, if I know that this over here is 1, I know that A has to be negative, by the way. The value of A must be a negative. So straight away I can exclude E and D. So how easy is it to find the value of A? It's very easy. This is the distance that we want to find, this value of X. This will give us our value of A. And yeah, so if I know that distance over here is 1, so if it's a right angle triangle, this is hypotenuse, and this is your adjacent, I know I'm going to be using tan inverse of the opposite, which is in this case X, over 1. And that should equal 2 pi on 3. So X is just tan of pi on 3, which is √3. So it means that this over here, your A value here is √3. That distance is √3, but we have to put minus √3 because it's the bottom of the imaginary axis, meaning that, yeah, your value is A. Very nice and easy. I mean, you can easily do this in your calculator. I mean, you know that formula for finding the polar angles is always, the tangent inverse of, your value of the first, which is the imaginary, like A, divided by this one over here, which is -1. And you can easily calculate it using your calculator, which, should, and we know that equals to -2 pi on 3. Let's try to do this on calculator. You can easily do this in a calculator, how quick. So you can just have to write, if I know that the angle of, oops, what happened? So the angle of, so even that's your argument, -1 plus A times I should equal to -2 pi over 3. And I can just solve for answer, comma A. Beautiful expression right over. A equals -√3. All right, so let's look at question 6. So question 6 says the points of corresponding to the 4 complex numbers is given here. Are the vertices of a parallelogram in the complex plane. Which of the following statement is not true? The acute angle between the diagonals of the parallelogram are 5 pi on 12. The diagonals of the parallelograms have a length of 2 or 4. Look, it's very hard to kind of visualize this. So what we want to do is actually just draw a diagram to visualize this nicely. So I just draw a nice diagram over here. So again, this is your real axis. And this here is your imaginary axis. So let's try to plot Z1 here. So Z1, let's put it with the color orange. Z1 is pi on 3, which is 60 degrees, so it's around here. And it has pretty much a length of 2, so this is Z1. The next one is 3 pi over 4, which is approximately pi over 4, so 45 degrees in this quadrant over here, but it has a length of half of the Z1 because it's the radius is 1. So what I'm going to do is right approximately right there. Is a half? Could be better. So like that. Right over here, and that is Z2. The next one is Z3, which is white. It has a length of 2, and it's from -2 pi on 3. So -2 pi on 3 is, imagine that we're saying this over here is negative 120 degrees. So if I'm not mistaken, if I know for a fact that this is 90, approximately it would be around here, but then it will be reflected, so it will be around here. So that, and I know that is here. So I know that this angle over here, let's actually draw those angles actually. This angle over here is pi on 3, should be pi on 3. The angle for this one over here is, z squared is pi on 4. This angle over here is pi on 3. And your final angle is negative pi over 4, which is approximately just over here, and it has a length of 1. Z to the power of 4, and it has pi on 4 here. Nice, so we've got these beautiful expressions, and we know it's a parallelogram if we put it all together. So if I do that right now, bring these all points together, we know this should be a parallelogram. All right, nice. It's just Z3. Okay, so it says, let's check. First, the first one says the acute angle between the diagonals of the parallelogram is 5 pi on 12. And we want to check which one's not true, so which one's false. So, okay, this angle over here tells us the angle between the diagonals, and also this one over here. So if I just add these two, so what's pi on 3 plus pi on 4? That's 7 pi for a 12. 7 pi on 12. That's wrong. So that angle between those diagonals are 7 pi on 12. What about the other ones? So this one over here. Well, I know it's pi on 6 plus, because I know this is here is pi on 6, and this one here has to be pi on 4, which is 10 pi over 12, 18, 24, 24, which is 5 pi on 12. So this, between these diagonals, the actual angle between them is 5 pi on 12. So this makes, it is true between these two over here. So we can maybe put a question mark. We're not 100% percent sure that, because it's also wrong. So what about B? The diagonals of the parallelograms have a length of 2 and 4. Yes, they do. Yes, you see. This one over here, you remember what the length of the diagonals is. Let's look at this one over here. The length is 4. Remember, this one here is 2, and this one over here is another 2. So it's 4, whereas this one over here, adding both of them is just 2, because this one's 1 and this one's 1. 1 plus 1, 2. So yes, also this is true, so this is wrong. We want the false. Next one, multiplying them all together should equal 0. Well, let's check that. So if I multiply all of them, that should equal 0. What I'm going to do is I'm going to multiply this with this one first, because they have a radius of 1, so it's going to be cis 2 pi on 4, which is just pi on 2, actually, multiplied by these two together, which is 4 cis 1 minus 2, which is negative pi on 3. We've got that, and so that will be 4 cis, what's pi over 2 minus pi on 3, which is 3 pi minus 2 pi, which is pi on 6. So pi on 6. No, this is not equal to 0. So this over here is false. It could be that one too. So this one's absolutely false. So it could be C, 100% C. Whereas this one over here is false, but also true. So let's check the other ones, to be 100% sure. Z1 plus Z2 plus Z3. Okay, now adding, complex numbers, the fastest way that I'll do this is think of them as vectors. For example, look at this over here. Can you see how, as we've drawn it, it goes like this? So it starts off like this. That's that one, and we call that Z1. And this one, Z3, this one over here, is we can draw as this. Can you see how, even from the diagram, as we can see, can you see how they are, in other words, if you think of them as vectors, if you add them, they actually cancel out, so that becomes 0. Okay. What about Z2 plus Z4? Let's try that, because, they both have a radius. So this one would be like over here from the diagram, and the other one would be over here. Also, these two will cancel out, so hence, pretty much adding them all together actually, is equal to 0. So D is true, so that's 100% wrong. And also E says that Z, so where Z, represents all of them, the magnitude of Z is between 1 and, root 2. That's true, as you can see from all of them. That's 2, that's 1, that's 2, that's 1. Yes, so that's absolutely true. So that's wrong. So 100% it should be C, because C is absolute, whereas A is true, but also not true. So A could be right. Yeah, so C would be the most best possible answer for that one. So choose C. Question 7 says, given that x is equal to sine t minus cos t and y equals this, then dy dx is what? Okay, nice. So, okay, what about find the derivative of this in terms of, so if I can find the derivative, which is dx dt, that'll be, cos t plus sine t. Yes. If I find the derivative of this, it's dy dt. Cos 2t. And I want to find dy dx, which is what? So if I just use the kind of, think of it like this, if I multiply dy dx, multiplied by this, but the kind of, 1 over it, so it will be dt dx. Can you see how now, oh, sorry, this is supposed to be gt. Can you see how these two cancel out, which gives us overall dy dx? So let's do that. So we're multiplying cos of 2t by this one, but 1 over it. So 1 over cos t plus sine t. All right. So that doesn't give us any. Well, this one looks similar, but it has a minus, so no. Okay, cos 2t, if you look at your actual formulas, your double angle formulas, you should see a relationship. Aha! This expression right over here, that cos t, can actually be simplified further. You can, replace that cos 2t with, cos squared t. So yeah, so it will be, so cos squared t minus sine squared t all over cos of t plus sine of t. Now, you should see this over here is just, differences of perfect squares, so that just simplifies to, cos of t, plus sine of t. If I just bring this kind of over here. Bring it here. Cos of t minus sine of t all over cos of t plus sine of t. These two actually cancel out, leaving us with our final answer of cos t minus sine t. So which one looks like that? Cos t minus sine t? A looks like your answer. Question 8. Using a suitable substitution, where a and b are real numbers, constants, can be written as what? Okay. Alright, so if we let u equal x to the power of 4 for this case, and you find your dx, which is just 1 over the derivative of this, which is 4x to the power of 3 multiplied by du. Okay, so let's rewrite this whole expression. So this will be, the integral. Well, a is what? If you sub in a here, it'll just be a to the power 4. If you sub in b, it should be b to the power 4. X to the power of 3 multiplied by e to u multiplied to get, dx we know is this. So multiplied by 1 over 4x to the power 3 du. So we can cancel those out. We can take that 1 over 4 out. A to the power 4, b to the power 4, e to u du. So which one looks like that? D looks like your answer for that one. Nice. Question 9. If f of x dy dx is this, where y naught is this and y of 2 is that, it's equal to that, so in y on 3 using the Euler's formula with the step size of this. So this is your h value, this is your step size, and we want to find y3. So you should know by Euler's formula, it's in your formula sheet if you're not 100% sure what it is. It states that, okay, we know our x naught in this case is the 2 here. And our y naught in this case is 0. So y1 is what? y1 is y0, what's our y0, which is 0, plus your step size, which is 0 0.1, times your f, which is, the derivative, so f of your x0, which is, in this case, 2. Okay, perfect. What about, that's your y2, so, and then your x1 is just 2 plus your step size, which is, 2.1. So to get y2, again, it's y1, so we calculate y1 to be 0 0.1 f of 2, plus your step size, which is 0 0.1, times your f, and it's going to be f of 0, 1. F of x1, which is, in this case, 2.1. Done. What about y3 now? y3 is what? Now, we know I need to first calculate x2, which is, 2.2. It's just adding 0 0.1. Y3 is, we know it's 0 0.1 f of 2 plus 0 0.1 f of 2.1 plus your step size, which is 0 0.1, multiplied by f of this value, 2.2. So having a look at the answers, it looks like it can only be C or D because it has 2.2 as we can, and we can easily simplify this over here using our CAS. And yeah, let's do that. See what that gives us. So using your CAS right now, so we're saying that, okay, if we define x, so f of x as 2x squared minus x, we get, what's 0 0.1 times f of 2 plus, 0 0.1 times f of 2.1. Enter that, and that gives us 1.272. So this expression, y3, is 1.272 plus 0 0.1 f of 2.2, which looks like C is your answer for that one. Nice. Question 10. Ooh, differential equations. Wow. The directional field for the differential equation dy dx is shown above. A solution to this differential equation that includes 0, 1 could also is what? Okay, so to do this is, okay, let's look at that point, 0, 1. So 0, 1 is this point over here. This point nicely. Let's try to follow the field, because, follow the field and see if it passes through these points. That will tell us this, one of these here is a solution. So if I'm following the field, I'm just going to slowly follow those field lines. Follow them nicely. And yeah, nicely follow them. See where they pass. All right, like that. That's what I've got. So let's check if 3, -1 is on this point on this graph. So 3, -1, so 3 is here, and -1, which is approximately here. Nope, that's not true. What about the next one, which is 3.5? So 3.5 is here. And we're going to -2.5, which is here. Yes, maybe I've drawn it not to be precise, but yes, that could be true. It's close to it. So we can put like a question mark on that. We know A is wrong. C, let's try to do C. Oops. Let me just drop that. -1.5, which is here. And -2. Nope, so we're talking about here. Nope, that's wrong. D is 2.5, so 2.5 is here, and -1, which is here. Nope. And 2.5, which is here, and 1, which is here. Nope. So the only possible answer would be B. Nice. That's how I would do this question. And you can easily, do this question using your CAS too. So, for example, I want to solve, what I will do is, okay, get the equation of dy dx. So dy dx is -x minus y. So having this equation, let's go on our CAS, go on graphs and go on menu, go to graph entry and go to differential equation. And I'm just going to change this to, this. And what's the expression? We said -x minus y. And the point that we know is 0, -1. Enter. Oops. Enter. And we get this over here, a beautiful expression over here. So let's check if the answer 3.5 and -2.5 work in this equation. So 3.5, which is 1, 2, 3, 3, and which is 3.5 is approximately here, and -2.5, which is here. Yes, perfectly fits on the graph. So yes, that's true. Done. So question 10 is that. Question 11 states, let alpha equals, so let the vector A be this and B be this, where A is a real constant. If the scalar resolute of A in the direction of B is given by this, then alpha is equal to what? Now, this is a nice, beautiful question. You can straight away, you should know the formula for a scalar resolute. The scalar resolute is just the A dot B over, so in the direction of B, which is, the magnitude of B. And yeah, so what is A dot B? In this case, so A dot B, for this case, is just A dot B is going to be 3 times 4, which is, 12, plus 2 times -1, which is -2. So I can just take that, put it here. And its next one is alpha times, so which is, alpha cubed. And, simplifying that, it's just 10 plus alpha cubed. So the magnitude of B is easy. So the magnitude of B is just the square root of 16 plus 1 plus alpha to the power 4. And we're just saying 10 plus A to the power 3 divided by, this expression right over here. So it would be square root of 17 plus A to the power 4 should equal 74 over square root of 273. Use our calculator to solve this. So go on your calculator and say, solve 10 plus A to the power 3 square root 17 plus A to the power 4 should equal 74 square root of 273, comma A. Oops, I didn't write comma here, comma A. And A should equal to 4, so D is your answer. Now you can easily do this in CAS very quickly. I just want to show you the algebra, but for example, if you want to do this, in a second, what I would do straight away is, okay, let's define A, the vector A, which is, you can write it in the matrices. So we press this over here. We know it's 3 to alpha. We'll call alpha, because we don't want to use A, we're already using A. Let's call it R in this case. Let's call it R, the thing that we're trying to find. Enter. And the vector B is just 4, -1, R squared. Oops, didn't write in vectors. So 4, -1, R squared. Is that right? So we've got these beautiful expressions. So what I want to do is, we know that the vector is the dot product of A and B and the magnitude of A and B. So to get the dot product, you go menu, you go to matrices and vectors, you go down to vectors, and you go to the dot product. We want the dot product of A and B, and we want the magnitude of B, so which you just write norm of B. And you pretty much, that's the, enter that, and it gives you this expression. And we just want to solve that over here, which should be equal to 74 square root of 273, comma R. Enter, and it gives you I equals 4. So yeah, you can also do that in your CAS very quickly. So let's move on to question 12. If, the vector A is this and B vector is this, where M is a real constant, the vector A minus B will be perpendicular to the vector B where M is equal to what? Okay, let me just give you an expression here. So for a vector to be perpendicular, we know that the dot product between them should equal 0. So for example, we want this vector over here to be multiplied by this vector, the dot product should equal to 0, and we can use that expression. So let's just call C, this expression over here, C. Let's put them all together. So C is just A minus B. Let's put them all together. So we're saying that C is, -2, so -2i minus j plus 3k minus b, which is, plus mi minus j minus 2k, and that is equal to, we can just write m minus 2i minus 2j plus k. So we got this beautiful vector, and that's your C vector. And we want this C vector over here to be perpendicular to B. So we want the dot product between C and B to be equal to 0. That is when we actually get perpendicular, for them to be perpendicular. So again, you can easily do that in our CAS. So let's define the vector C. So vector C is going to be oh wait, let me control N because we're using A and B already. So just control A. Okay. So vector C is the vector, as we calculate it, is n minus 2. So m minus 2. So m minus 2, negative 2, 1. And your B vector is negative m 1, 2. So we want the dot product, so go menu, go again on matrices vectors, go down to vector, and we go dot product of C and B, and we know that should equal to 0. And we want to solve answer, comma m. And we get m equals 0 and m equals 2. Those are your two answers. So m equals 0 and m equals 2, that is your C is your answer. Question 13. A particle of mass 5 kilogram is subjected to a force of 12 newtons and 9 newtons. If no other force acts on the particle, the magnitude of the particle's acceleration is 1. Okay, this is nice. So we know that the formula, the sum of all forces is equal to your mass times acceleration, yes? So imagine these two forces are being applied to the mass. So just add them. We want, it's the sum of forces, so it will be just, 12I plus 9J is equal to your mass, which is 5 kilograms, and your acceleration, which is what we're trying to find. So, A. So your acceleration is just a vector, which is, 12I plus 9J divided by 5. And let's just, so what's 12 divided by 5 and 9 divided by 5. Okay, so that is just 2.4 I plus 1.8 J. Now look at the question. It says the magnitude of the particle's acceleration. This is a vector. We want the magnitude. So we want the magnitude of A. So it's just going to be square root of 2.4 squared plus 1.8 squared. And that's going to give us our magnitude, which would be, just a calculator. This one over here, squared. This one over here, squared. Gives us 3. So that is your acceleration. So choose A. Question 14. 2 light strings of length 4 and 3 connect a mass to the horizontal bar. As shown below, the strings are attached to the horizontal bar 5 meters apart. Okay. Given that the tension in the longer string, so T1, and the tension in the shorter string T2, the ratio of tension T1 and T2 is what? Okay. What do we know? So because we know that given that the tension is longer, so this force over here, given the tension in the longer string and the tension in the shorter string, the ratio of T1. Okay, just visualize it. If you have a longer rope over here and you have a shorter rope, which one will highly likely have the highest tension, the force of tension? It will be T2, the shorter rope, because remember, it's like the one that's actually going to have that strong tension force. So what do we know? If we want, imagine just having a look here, T1 over T2. If I know that T2 is going to be greater than T1, what does that tell me? It tells me that T1 over T2 pretty much must be less than 0. Oh, no, sorry, it must be kind of less than 1, if I'm not mistaken. Yeah, wouldn't that? Because imagine that the denominator is bigger. So it means, yeah, it must be less than 1. So just knowing that, I should look at the answers and say, okay, this one here is greater than 1. Cancel that one. This one's also greater than 1. Whereas the other ones are, yes, less than 1. So that's good. We can just eliminate that. What I'm going to do here, okay, let's think. If I know this is 4, this is 3, and 5, isn't that a perfect right angle triangle? Just by looking at that, by using Pythagoras theorem. So I know for a fact that this over here is a right angle triangle. And, okay, I know that now. What can I do? Well, if I can, if I know this is the right angle triangle, you know that if I know that is the right angle triangle over here, let's calculate these two angles over here. And what I'm going to do is I'm going to break down these vectors actually. Break this vector here and break down this vector over here. And so if I break those down, and I want to break them down to its horizontal, so this one's going to be looking like this, goes up. This one's going to go like this, and it's going to go up. So, because if I find this angle, it's the same as this angle. So let's do that. So I know this is your hypotenuse, and let's try to find this angle. So it means this here is your opposite. This angle here is your opposite. So we can just use sine theta, which is just theta over here, is equal to your opposite, which is 3/5. So using your calculator, so I'm going to use, so what's the inverse of sine? So inverse of sine of 3/5. That, and I'm going to take this over here and make it to degrees, 180 over pi. That gives me 36.86 degrees. So this over here is 36.87 degrees actually. And I know from this one, it's because I know a right angle, so a triangle has the degrees is all in total 180. So it's just going to be 180 minus this one over here plus 90. It's going to be 53.13. 53.13. Okay, now we know there's two angles over here. And these angles should be parallel, so they should be this same angle here. And I want to calculate these two forces over here. These two forces. And so let's do that. So this force over here, if I know that the angle, this is tension, so that's your hypotenuse as your tension. All right, this is your right angle, and I want this one over here, which is your cos. We're going to have to use cos here. So it will be the force here, T1 cos theta over here. Whereas this one over here, well, cos theta in this case is what? It's the 36.87 degrees. And I know this one over here is going to be T2 cos 53.13. So if I add these two vectors, so this one's T1 cos 36.87 degrees, should equal, because they're in equilibrium, should equal to 2t cos 53.13 degrees. And now it's very easy. I just want the ratio T1 over T2. So T1 over T2. So let's divide all by, so what's T1 cos 36.87 degrees divided by T2 equals cos 53.13 degrees. So therefore T1 over T2 is just cos 53.13 degrees over cos 36.87 degrees. Is that right? Yes. So let's use our calculator. So I'll put that over here and put it in degrees. And cos of 36 over here in degrees. And we get 0.75, which is, from all those answers, it's 3/4 if I'm not mistaken. 3/4. Yes, so choose B as your answer. Question 15. A variable force of F newtons acts on a 3 kilogram mass so that it moves in a straight line at time t seconds, where t is greater than 0. Its velocity v meters per second and position x meters from the origin is given by this. It follows that what? So we know that by, we want to find actually, what are we trying to find? So it follows that, okay, what is the force? So again, force is just mass times acceleration, yes? And so this here is our vector velocity. This gives us our velocity. So we know to get the acceleration, we want to get acceleration. It's just the derivative of the velocity. So we just need to find, not derivative of it, but we need to find the expression that gives us the acceleration. We know from our formula sheet that acceleration is if you look at the formulas, if you have a look over here, it says that d dx of half v squared gives you acceleration, doesn't it? So let's use that. So acceleration is what's v squared? V squared is 3 minus x squared, multiplying it by half, and finding the derivative with the respect of dx of this expression. So let's use our calculator for that. So it will be menu, actually just go on derivative with the respect of, so what's half times 3 minus x squared. It gives us x minus 3. Wow, that's a very simple way. So x minus 3, I don't know why. Yeah, so x minus 3. This over here is our acceleration now. So we just say, am I not mistaken? Yeah, is that right? Have I done everything right? So 3 oh, no. I forgot to put a squared over here because it's 3 minus x squared. Yes, and then, okay, let's do that. So come back to our calculator, put a squared over here. And we get this expression. If I'm not, yeah, so this, okay, so we can just change this to 2x x squared minus 3. That's your acceleration right over here. Multiplying by the mass, which is 3 kilograms, so it'll be 6x x squared minus 3. That's your force. So which expression looks like this? Looks like D is your answer for that one. Nice. Question 16. A cricket ball is hit from the ground at an angle 30 degrees to the horizontal with a velocity of 20 meters per second. The ball is subject to only gravity and air resistance is negligible. Given that the field is level, the horizontal distance traveled by the ball in meters to the point of impact is what? If you do physics, guys, this question is very easy. This is called projectile motion, and pretty much is, okay, let's think about it. We have a horizontal floor over here, and imagine like hitting a ball at a velocity of at 30 degrees, and we know that it's been hit at a velocity of 20 meters per second. So the ball is going to go up, and it's going to go hit a point, which is somewhere around here. And we want to calculate this horizontal distance, this value of distance over here, this distance. So how do we do that? Well, okay, let's break these components into its vertical and horizontal components. So this velocity vector, Let's look at its vertical components. We know by having a look over here that when the ball is over here, the vertical component of its velocity actually is 0. We also know that acceleration is just negative 9.8 for this case. And what else do we know? Okay, that. So, and we know that we just want to try to find the time, because what we can do is if we can find the time that it takes the ball to go to this point over here, we just double it, because then it will give us the time it hits the floor. So yeah, so we want to find the time, and we also know the initial velocity, which is, the vertical components of this, so which is, in this case, it is 20 sine of 30 degrees. So we have everything. So using your formulas, you should know that if the formula is V equals U plus AT, so, and we want to find T, so it's just V minus U over A, and that should equal to T. So your velocity is just 0 minus 20 sine 30 degrees all over acceleration, which is negative 9.8. So using your CAS to solve the time will give us, the time it takes for the ball to reach the peak of the, oh wow, it's not going down, and then we just have to double it. Okay, let's do that. So we're saying negative 20 sine 30 degrees is just pi and 6, so let's write that, pi and 6 is negative 9.8. That gives you 1.02. So this is the time, so we just double it. So that is the time it takes for the ball to actually reach the floor, their point of impact. So let's write that down. So our time is 2.04, 0816 seconds. Now it's very easy. Now have a look at these horizontal components. The horizontal components just has no acceleration. It's a beautiful constant acceleration formula. We just, we can easily use distance is equal to the velocity times time. And we know that the velocity is the horizontal velocity, which is, 20 cosine 30 degrees, multiplied by the time, which we've already calculated to be, 2.04. So let's use our calculator for that one. So this times 20 cos 30 degrees, which is pi on 6. And that over here gives me 35 point blah, 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 which, let's have a look at the answers. That's going to be, well, so that's going to be, is it 200 root 3? Root 3 over g, which is 9.8. Aha, they're the same thing. So yeah, it's d. I should have actually looked at the question and used g as not a variable. So I should have used this over here as negative g. So it would have made my life easier. So for example, this here would be negative g over here. So your time would be all in, terms of g. But yeah, so d would be your answer for that question. Nice. Question 17. A body of mass 3 kilograms is moving to the left in a straight line at 2. So imagine something that's moving to the left at 2 meters per second. So I always take the convention as negative because we're talking about velocity. And yeah, I'm going to take it as negative. It experiences a force for a period of time, after which it then moves to the right. So if experiences a force and then after it moves to the right. So now it's plus 2 meters per second because it's in the positive direction. The change in momentum of the particle in kilograms per meter squared, meters per second in the direction of the final force motion is what? Okay, this is very nice. These all questions are from physics. These are very nice physics questions. So, okay, we know that momentum is P equals mass times your velocity, but we want the change in momentum, which is the impulse. So the change in momentum is just your mass times your velocity, final velocity minus your initial. So our mass is, in this case, is 3. Our final velocity is 2 minus your initial velocity, which was negative 2. So it's 3, 4, 8, 12. So it'll be 12. So choose E as your answer. Question 18. Oranges are grown on a citrus farm have a mean mass of 204 grams with a standard deviation of 9 grams. Lemons grown on the same farm have a mean mass of this and a standard deviation of this. The masses of the lemons are independent on the masses of the orange. The mean mass and the standard deviation in grams, respectively, of a set of 3 oranges and 2 of these lemons are what? So we have 3 oranges and 2 of these lemons. So we can say the set is how many oranges? So we have 3 oranges. So we can say orange plus orange plus orange plus 2 lemons. So 2 lemons. Okay. And we want to first find the expected mass and the standard deviation. So the expected mass is just the expected S of this, which is, just the expected value of O plus the expected value of O. And in other words, it's just 3 times the expected value. 3 times the expected value of O. And then the other one's going to be 2 expected value of L, which we've already know that the expected value of the oranges is 204 plus 2 standard deviation. The mean of lemons is 76, which is, using a calculator, 3 times 204 times, times 76, that's 764. 764 grams. So we can actually cancel that out, cancel all these out. So we only have A and C now. We need to find the standard deviation now. So think of it in terms of variance. So let's first find the variance of S. So again, the variance of S is going to be the variance of O, so which is just 3 var of O, same as that, and plus variance of L, and variance of L is just going to be 2 variance of L, which is the variance of O is what? it's going to be 9 squared, which is 81, plus the variance of lemons, which is 9. Let's calculate those. What's 3 times 81 plus 18? That gives me 261. And taking the square root of 261, which gives us the standard deviation, we get 3 root 29. So 3 root 29, and that's going to give you your standard deviation of S, which is A as your answer. Nice. Question 19. A random sample of 100 bananas for a given area has a mean mass of this and a standard deviation of this. Assuming that the standard deviation obtained from the sample is sufficiently accurate estimate of the population standard deviation, an approximate 95% confidence interval for the mean mass of bananas produced in this locally is given as well. A very nice question that you can easily do with your CAS. So we know that the mean mass, so your sample mean is just 210. We know that there are 100 bananas, so your n value is n, and your standard deviation, your S value, is just 16. Is that right? Yeah, and we just need to find 95%. So just go on your calculator and go on menu, go on statistics, confidence intervals, and go to Z interval, and change data to stats. Okay, so again, this is your standard deviation, which in this case is 16, your sample mean, which is 210, your n value is 100, and we know we want the 95% confidence. Okay. Control Enter, and we get your C lower and your C upper, which is, from having a look at these, B looks right. Done. Question 20. The lifetime of a certain brand of batteries is normally distributed with a mean lifetime of 20 and a standard deviation of 2 hours. A random sample of 25 batteries is selected. The probability that the mean mass, so we want the probability that the mean lifetime of this sample of 25 battery exceeds, so let's call it X sample exceeds 19.3 is what? Okay, so the expected value of X this is what? It's just the same as the expected value, the mean value, which is 20 hours. The standard deviation of the sample mean is just your standard deviation of the normal, so which in this case is 2, divided by the square root of the value of n, which is 5. Is that right? Yeah, so in a standard deviation of 2. Perfect. So, okay, so we got 2 over 5, and we get these two values. So now we can just use, we know that the probability, we know that the standard deviation and stuff here, we can just use our calculator now. Perfect. So go to normal distribution. So go in menu, probability, distributions, the normal CDF. We want 19.3 to infinity. Your mean value in this case is 20, and your standard deviation is 2 over 5. And that gives you 0.9599, which is E. Perfect. We've just smashed through this paper. I hope you guys enjoyed this video. Please make sure like and subscribe and share it with your friends. It pretty much means a lot to me. I hope you guys really enjoyed this video, and please share it with your friends. And have a good day, guys. Bye bye.